The last video for 5.2, we're going to talk about Pythagorean identities and then quotient identities. So Pythagorean identities comes from, of course, the Pythagorean theorem, right? So as we look at a right triangle, we notice that our x was here, right, and our y, switched it. Our y is here, our x is here, and then we have our r, right? So when we do these Pythagorean theorems, if we look at this distance, if we let r equal 1, then basically our sine would be y over 1. So sine would equal y. Sine of theta would equal y. And cosine of theta would equal x. So we can see we get x squared plus y squared equals 1. And since y equals sine and x equals cosine, if r equals 1, then we have sine squared of theta plus cosine squared of theta equals 1. And then we can also have these other trig functions. Tan squared of theta plus 1 equals secant squared of theta, and 1 plus cotangent squared of theta equals cosecant. That's an S here. Cosecant squared of theta. Now you can rewrite these and solve. I could rewrite this and solve for sine. I could rewrite it and solve for cosine, or sine squared and cosine squared, or I can do sine, right? Solve for sine or solve for cosine. Same with these. Solve for tangent squared or tangent, and then solve for cotangent or cotangent squared. Same with cosecant. And get rid of that, right? So then cosecant is by itself. Now another way to write these would be sine theta squared plus cosine theta squared. So you're not squaring the angle. Never square the angle. If they give you the angle, don't square it. So what you do is, like for this example right here, I'm trying to find sine of theta when cosine of theta is 2/3. So cosine of theta is 2/3. So instead of writing cosine of theta, I'm going to write 2/3. So first of all, I want to look at what I'm trying to find and what am I given and which of these trig functions relate. And this first one, right, sine squared of theta plus cosine squared of theta equals 1. So what this means I'm going to do is I want to find sine, but sine is being squared and so is cosine being squared. So I can really look at it, this top one right here is the same thing as the one in green there. Now cosine of theta is 2/3, so this is 2/3. So 2/3 being squared. So I'm taking 2/3 and I'm squaring it, because I'm squaring the cosine, right? Cosine is being squared. So I take what cosine is, 2/3, and square it. Okay, this 2/3 is not the angle. Alright, so I'm not taking cosine of 2/3, I'm taking 2/3 and squaring it. And that equals sine squared of theta. Or adding sine squared of theta, and that equals 1. So now we square that, we get 4/9. Now we subtract 4/9 on both sides. This will turn into 9/9, so 5/9 equals sine squared of theta. Now I need to get rid of that squared by square rooting. So I get sine of theta equals square root of 5 over the square root of 9. And I square root, I have plus or minus, right? Square root of 5 over 3. Now, if I know what quadrant I'm in, then I can see if it's positive or negative, right? But I don't know what quadrant I'm in, so it's plus or minus square root 5/3. So just make sure the other way to do this is possibly it was cosine of theta equals 2/3. Well, cosine is equal to x over r, so you can let your x equal 2 and your r equal 3, and then you can solve for your y by doing Pythagorean theorem. But you would have to subtract 3 squared minus 2 squared, so 9 minus 4 squared, which is 5, and then square root that. And see how we get square root of 5 for our y. But we don't know if that's a plus or minus. We don't know if y is a plus or minus. So we need to have that plus and minus out front. So now let's take a look at some of our quotient identities. Right, so if sine is y over r, and I'm dividing that by cosine, which is x over r, Remember, when I'm dividing by a fraction, I can flip it and multiply by its reciprocal. So y over r times r over x. So these would cancel, and I would get y over x. Isn't that what tangent's equal to? So that's why sine of theta over cosine of theta is tangent of theta. Same thing if you just flip it, right? You get cosine of theta over sine of theta, which is cotangent, because these two are reciprocals, right? So let's go ahead and work on some examples of dealing with both these types of identities. So let's look at one. Let's look at this one. Okay, so here we go. We have sine of theta. We want to find sine of theta and tan of theta given cosine of theta, and sine of theta is bigger than 0. So that sine of theta is bigger than 0 just lets us know that our answer for sine is going to be positive. Okay, and we can go ahead and look at, hey, if sine of theta is positive, that means we know we're up here, right? And if cosine is negative, which it is, we know we're over here, so that means we know we're in the second quadrant, so we know that sine is going to be positive and tangent will be negative, right? So that means our x is negative. So since cosine of theta equals negative square root 3 over 4, this is x over r, so we know where x is negative, right? So we know we're over here, and since sine is positive, we know we're in the second quadrant. Okay, so you can do this without the Pythagorean identities, right? Because I could use this x over r and let my x equal negative square root 3, my r equal 4, and then I could use Pythagorean theorem and solve for y. What they want you to do here is use those identities, because when in the next chapter when we're going to prove identities, and we're going to need to know what these Pythagorean identities and these quotient identities are in order to prove some identities, okay? So you're going to have to rewrite stuff. So it's good practice get into these, even though you might see, what's the point? I can just use x over r and solve for it. Yes, that's true. But you want to get practice with using these identities and being able to rewrite stuff. Okay, so we'll go ahead and just use the identities. Okay, so I want to find sine, and I'm given cosine. Well, which identity can we use? So that identity is sine. If you want to write it like this, that's fine. But sine squared equals cosine of theta squared equals 1. And so I have my cosine, which is negative root 3 over 4, and I'm squaring that, right? Because cosine of theta is negative 3 over 4. Right? This is not my angle. Negative root 3 over 4 is not my angle. It's what cosine is. Okay, so then we can square that, so then we get a positive, right? Negative times negative is positive. Square root 3 times square root 3 is 3, and 4 times 4 is 16. Okay, so then we can subtract 3/16. So that'd be 16 over 16 here, so we get 13 over 16 equals sine of theta squared. Now we can square root both sides, so square root the top, square root the bottom. So sine of theta equals root 13 over root 16, so sine of theta equals root 13 over 16. And we know, oh, not 16, 4. Square root of 16 is 4. And we know this is positive from right here, right? So, and we're in the second quadrant. So there's our sine. So sine, here's our first answer. Sine of theta equals root 13 over 4. Okay. And now we're going to use the fact that we're trying to find tangent, and we know tangent of theta is equal to sine of theta over cosine of theta. Now again, you can use your x over r, right? Because now you know your y, and tangent it's y over x, so you know your y and x, so you could plug those in, yes. But what we want to do is we want to use this identity, okay? So sine is root 13. Sine of theta is root 13 over 4, and I'm going to divide that by my cosine, which is negative root 3 over 4. Dividing by a fraction, it's like multiplying by its reciprocal. These 4's are canceled out. We get root 13 over square root 3, and it's a negative, right? Because we know this answer is going to be negative because we're in the second quadrant. So this is what tan of theta is. We rationalize it. So So we get square root 39. That's not going to break down, right? Because you got 3 and 13, no pairs. 3 on bottom, and it's a negative. So there's tangent, and there was sine from above. Okay, let's go ahead and do another one. Okay, so we want to find cosine of theta and sine of theta given tan of theta. Okay, tan of theta is 4/3. And we're in quadrant 3, so that lets us know if we're in quadrant 3, we know tan's positive, right? Which they already give us positive 4/3. But what is sine and cosine? Both negative, right? So we know these answers. Cosine of theta is going to be negative something, and sine of theta is going to be negative something. Okay, so now we can solve this again. I know this is your y and this is your x, so you could use that, but we want to use these identities, right? And so we don't have a straight relationship. We have a straight relationship between these two, sine and cosine, but we don't have a relationship directly between sine and tangent or cosine and tangent. The only close one we have is cosine and tangent, not directly, but we do have secant of theta and tangent of theta. So we're going to use that one first, and then we can just flip that fraction and get cosine, and then once we have cosine, then we can go ahead and find sine. So we're going to use this one, tan of theta squared. Again, just squaring your tangent of whatever your tangent's equal to, which is ours 4/3. And then we're going to add 1. That's going to equal secant squared of theta. Alright, so really we need to get secant by itself, so we're going to square root this side, square root this side, right? So secant of theta will equal the square root of our tan squared, right? So that's taking 4/3 and squaring it. Again, this is not the angle, this is our answer. Okay, so we're going to take 4/3, we're going to square it, and we're going to add 1, and then we're going to square root it. And when we square root, we know we get plus or minus, but that's okay because we already know we're in the third quadrant. We already know cosine's negative, sine's negative, so we don't need to worry about a plus or minus. Okay, so we get 16, oops, sorry, I'll erase that. So we get 16 over 9 plus 1, which is 9 over 9. So we get, and then we're going to square root it. So that's 25 over 9. Square root it is 5. Ooh, that's an ugly 5. 5, even probably uglier, over 3 is equal to secant of theta. But cosine we know is the reciprocal of secant. So all we have to do is just flip that. So 3/5 is equal to cosine of theta. So now once we have cosine of theta, you could do two different things. You could use the Pythagorean identity of sine squared of theta plus cosine squared of theta equals 1. We could use that, or we could use the fact that tangent of theta is equal to sine of theta over cosine of theta. I think this bottom one is probably easier to use because we know tangent is 4/3, and we know cosine is now 3/5. It is negative, but we'll deal with the negative. We already know this is going to be negative, so we'll deal with that. Don't worry about it right in here. Okay, so dividing by 3/5, right? How do I get rid of that? I multiply by 5/3 on both sides. I multiply by 5/3 on both sides. That means these are going to cancel over here, and so we get 20/9. So sine of theta is 20/9, and we know it's negative, right? Because we're in the third quadrant. So those are our answers, and we can go ahead and we could reduce that to a simpler fraction. Negative divide by I don't want to times by 5/3. Let's come back up here, because that is timesing by 5/3. Dividing by 3/5 is, so we had 3/5, so that's the same as multiplying by 5/3, right? So that's taking sine of theta and multiplying by 5/3. So how do we get rid of dividing by 3? We multiply by 3. So we're actually going to multiply by 3. And then how do we get rid of we get rid of dividing by 3 by multiplying by 3. How do we get rid of multiplying by 5? We divide by 5. So these 3's are going to cancel. We actually get 4/5, and it's going to be negative 4/5. I'll do that real quick again. Okay. So my tangent was 4/3, and equals sine of theta over cosine of theta, and cosine of theta is 3/5. Right? So how do we get rid of dividing by 3/5? We multiply by 3/5, right? Because we're dividing by 3/5, we want to do the opposite, which is multiplying. So those are going to cancel, and I have to do this side 3/5, and that's why the 3's cancel. We get 4/5, and we know it's negative because we're in the third quadrant. Okay, let's work on some homework problems. So here you go on page 498, number 131 and 133. So number 131, we're looking at cotangent of theta is equal to square root 3/8, and we're in quadrant 1. So that means everything's positive, right? So again, you could use x over y. This one is x over y, and then you can find r, and you can find what we're looking for here, and we're actually looking for the other 5 trig functions. So we want sine, cosine, cosecant, secant, and tangent. Okay, so we want the other 5. So you could use your x over r, but they want you to practice with those identities, right? So we do have a cotangent identity, and that is cotangent squared. You can put the squared here, or you can put the theta and then put it in parentheses and square that. However best you understand it, right? You're not squaring your angle. This has nothing to do with an angle, right, that you're squaring. You're squaring what cotangent is. Okay, so we have this Pythagorean identity that's taking cotangent squared, adding 1 to it, and that equals cosecant. Okay, cosecant squared of theta. Alright, so first of all, because we have cotangent, then it's easy to find tangent, right? So we can just flip this and get 8√3, rationalize that denominator. And I think we talked about this in the last video. Whenever I divide by a radical, aren't I just going to be multiplying by that radical and then divide by the radicand, the number underneath? Right, so there's tangent. So look, we only have 4 left. This is going to give us cosecant. So let's square cotangent. That's 3/64, right? Because square root 3 times square root 3 is 3. And then we're adding 1 to that. So that is 64/64. And then we're going to square root. So that is 67/64. We're going to square root that, and that's going to give us cosecant of theta. So cosecant of theta is the square root of 67/8. And then we look what quadrant we're in, quadrant 1, so we know everything's going to be positive, so we don't have to worry about plus or minus here. So there we have 1, 2. Now I can do the reciprocal of cosecant, which is sine of theta. So I flip that fraction. So that's 8/√67. But isn't that going to be just sine of theta? Sorry. 8 times √67/67. I can't reduce 8 and 67 now. So there's that. And then we can go ahead and find cosine. So you can do a lot of different things finding cosine. You can use the fact that you have sine and you have tangent, like we did on the last example. Or we can go ahead and use cosine squared plus sine squared equals 1. So that's fine too. Here you're gonna have to square 67, so that doesn't sound fun to do because I don't know that off the top of my head, and if you do, that's awesome, so you can do it that way. But I'm gonna use this tan of theta equals sine of theta over cosine of theta and solve for cosine, which you multiply by cosine on both sides, right? And then divide by tan. So cosine of theta equals sine of theta over tan of theta. So our sine of theta is 8√67/67. We're going to divide that by our tan. which is 8 root 3 over 3. 8 root 3 over 3. So we're going to flip that bottom one. So 8 root 67 over 67. 3 over 8 root 3. These are going to cancel. So I get 3 root 7, or 3 root 67 over 67 root 3. Multiply by root 3 on both sides. 67 times root 3. Square root 67 times square root 3 is 201. And that's not going to reduce because 67 doesn't reduce either. So we have 3 square root 201 over 67 times 3, which is 201. So there's cosine of theta. We can go ahead and flip that for our last one, secant. And we can go back to 201 over, this 3, I guess, this 3, right? And 201 will reduce to 67. Square root 201. So there's cosine of theta. And secant would be 67 over square root 201. So 67 over square root 201 over 201. 201 is going to reduce, right, by 3. So secant of theta will equal square root 201 over 3. So there's all 6 of them. Okay, so there's number 131. Now let's go ahead and do 133. So number 133. Okay, so here's 133. Sine is positive and cosine is less than 0, so that means it's negative. So that means we are in quadrant 2, because here cosine is negative and here sine is positive, so we're in quadrant 2. So that means sine and cosecant of theta will also be positive. Everything else is going to be negative, right? So if I flip this fraction, I get 6 over root 2, rationalize it. So we get 6 root 2 over 2. Divide 6 and 2, right? They're both outside the square root, so we can divide those. So cosecant of theta equals 3 root 2. And that's going to be positive. Now all the rest are going to be negative, right? So here we have sine, we have cosecant, and so now we can find all the other trig functions. Remember from our last 131 that cosecant of theta squared is equal to 1 plus cotangent squared of theta, right? So if I square this and subtract 1, then I'll get cotangent squared, right? Subtract 1 from this, subtract 1, and then square root. I'll get cotangent. So this would be, oops, let me rewrite it. So cotangent will equal cosecant of theta squared minus 1, and then square root it will give you cotangent. Once we have cotangent, we can flip it and get tangent as well, right? So we can take 3 root 2 and square it, 3 root 2 and square it. So that means I got to square the 3 and the root 2. So 3 times 3 is 9. Root 2 times root 2 is 2. 2 times 9 is 18. And then I'm subtracting 1, which is 18 over 18. Oh, I'm just subtracting 1. Just subtracting 1, which is 17. I was getting used to doing with fractions. So that is 17, so square root of 17. So there's cotangent. Cotangent of theta equals square root of 17. We can go ahead and flip that. So that would be 1 over root 17. Rationalize it. Means root 17 is on top, times by 1, and then divided by 17. So there's tangent. And then we can find cosine and secant. And we know these are negative, so let's go ahead and put negatives in front, right? So we know these are negative. Oh, put the negative here. There we go. So we know those are negative. Now secant and cosine you can do tons of different things. So secant squared of theta equals 1 plus tangent squared of theta. So I could square this tangent and add 1 to it and then square root it, right? And get secant. Right, that would give me secant, and then I could flip it. Or probably the easiest one, since we're given sine, you might as well do the most basic trig one, right? Which is sine squared of theta plus cosine squared of theta equals 1. So cosine squared of theta is equal to 1 minus sine squared of theta. Square root it, and we get rid of that squared. Right, and we know that's going to be negative because we're in the second quadrant. Okay, so this is probably the easiest one. I mean, now that you know tangent, once you know tangent and you know sine or cosine, you can always find the other one just like we did on the last example. But here's probably easy because we know sine, and sine is root 2 over 6. So we're going to do that root 2 over 6. Sorry. So root 2 over 6, we're going to square that. So it means I'm squaring root 2, which is 2, squaring 6, which is 36. I'm going to take 1 minus that, so that'd be taking 36 over 36, and minusing 2 over 36, which is 34 over 36. And we're going to square root it. So that's the square root of 34 over 6, because the square root of 36 is 6. So we know it's going to be negative. So there's our cosine. Now we can flip it, and we get 6 over root 34. Rationalize it. So we get 6 over root 34 over 34 is our secant. But we can simplify this 6 and 34 to 2, or sorry, to 3 and 17. We know it's negative. So those are all our answers. Okay, so that's how you do these type of problems. Again, you can do it with x, y, and solve for r, or you have your y and your r and you solve for x. That's fine. But you want to get practice with using these identities and being able to switch from cotangent to cosecant, from tangent to secant, sine to cosine, and all their reciprocals and their quotient identities.